Yeah. All right, so I'm finally here. I had a big snafu this morning. I had big errors. So with the Ninja Notes, everybody's doing pretty well with those. There's no reason really to turn those in early. You want to make notes throughout the week. You can make them however you want. Write them down. This is not a paper describing what we did in class. This is just notes of what you did. And so I simplified it a little bit, just saying, take notes on what you want to remember. Notes do not have to be complete sentences. They're just there to remind you of what you want to remember. So I'm not looking for a paper. I've had a few people kind of do papers and describe what happens in class. What I want is, oh, I learned about blip. And ethical hacking is meaning that we're hacking, but we're doing it with, permission of the business or something. Most people are just fine. Anyway, I'll give feedback as we go. All right, so Ninja Notes are working. I did find a couple really good videos. So this is a comparison video between TCP and UDP, and TCP and the three-way handshake explained. Well, did anybody read the chapter and remember anything about the three-way handshake? Uh-oh, this looks like it's in the wrong week. I better check that out. Or it's supposed to say week 3. I better fix that. So does anybody know what either of these mean? Three-way handshake? It's a good video. I found a series of videos by this guy. Oh, it's not, this isn't the one, but I found another one. He goes through this whole thing. So I send a message to Jess. Oh, we could do this as an in-class. So anyway, make sure you watch that video. I'm going to stop. Man in the middle. What does man in the middle attack sound like to you? Have you looked at that assignment or done any research on man in the middle?
Where you would intercept.
Yep, you put yourself in the middle of, remember that TCP handshake thing we were just looking at? You put yourself in the middle of that and you're pretending to be somebody else. Remember the MAC address business? Right? I can spoof my MAC address so that Jess thinks I am Mike. And so then when she thinks she's communicating with me, Mike, she's actually sending the message to me, and I'm sending that message to Mike, and he thinks I'm Jess. So I've got myself in the middle of that, which means then I can take a look at all the packets going back and forth, and I have my entire lifetime to descramble anything that's encrypted and find out what they're up to. Make sense? So let's go to look at that assignment a little bit because I can't remember exactly what I did. There's several different ways you can do this with Linux. I need to get this going, so I'm going to pause. Don't ever do what I'm doing. So overviewing TCP/IP, we have the application layer, and the application layer is for, what is the purpose of the application layer? What is the application layer? And our network stack is a common term to refer to that as, because the software is stacked in layers. The application layer is how an application talks to the network part of the computer. So Mike would have Obsidian on his computer. Obsidian talks to the application layer, and then this takes care of all the transmitting of all his stuff to his Obsidian, what is that called, a lock space or something?
Obsidian?
Yeah, it's a vault. It has a vault.
Vault.
Yeah, it has a vault. So Word, if you can save some, no, not Word, any internet browser does this. Anytime you're accessing the internet, the program is up here. It talks to this layer, which translates the program to the network stack. It does so that it's the right kind of stuff coming in. It starts the breaking apart and aligning process to prepare it to go over the network. All right, so Callie Bill. So the next stage is transport. Once we've got the packet kind of, not sliced and diced, but the right information entered into it so that it's converted into a form that the network stack can understand, we go to the transport layer. So the transport layer is
Transports it. Controls the flow of data.
Yep. So we have two types of transports. We have TCP and UDP. So TCP is We were demonstrating something about one of these services earlier this morning when we were doing the whole handshake thing. Which protocol needs a handshake?
TCP.
TCP needs a handshake because
It should know the source and destination exactly, and to make the kind of a tunnel between them, and it should be, say, protected, encrypted.
well, actually encryption doesn't happen at that layer.
Does it
TLS.
Well, maybe it does. I thought TLS was up here, but no, they did.
Does
They
it
moved it
trans-
down here. Okay, yeah,
does
you're
it
right.
translate the IP address? It
Nope, that's the
matters?
next layer, internet layer. So TCP is the three-way handshake. It establishes the synchronization numbers. It makes sure that we can communicate accurately. It's like if I say something to Mike, or Mike says something to me, and I say, I don't understand, then he would say it again, which
Yeah.
is what happens when you have a collision. You would say it again. So until I get that other part of the packet that I didn't understand, I'm not gonna go any further. And that will happen occasionally, and you won't see it because it happens so fast. Now go ahead.
Checksum that is checking.
There's checksums in there too. Yep. So it guarantees that whatever I say to Jess, she gets. And if she doesn't, then she says, sorry, send that packet again. That's part of the whole exchange, because if the sequence numbers don't line up and you're missing one, nothing happens until you get that missing packet. And if there's a certain amount of time that you don't get that packet, you will say, hey, Jess, try that one more time. Send me that packet. So there's all kinds of chatter in TCP IP to make sure it's reliable. Now, what about UDP? In fact, the first part of the acronym tells me what it is. TCP is reliable. It's connection oriented.
Yeah.
It's oriented by a connection. We have to have a connection to make it work. UDP is,
Unreliable.
Yeah, it's
exactly
and
unreliable.
it's mostly for fast connection, like streaming video or something like that, that does not require exact data sending
That's right.
byte by byte. Just if some packages will be lost, it's not so important.
So for instance, on this screen, as I'm recording it through Zoom, if there were, with every frame, which is typically 30 frames per second, we'll just say that I'm recording 30 frames per second on this video. If one frame was missing 10 bytes, which each byte would be a pixel, you couldn't even see it. If it was missing a few bytes out of my voice, you're not going to see it. You're not going to hear it, because there's enough there that you're going to hear it just fine. Now, you've had really bad connections where it go like that, right? That's not guaranteed delivery, but what's more important than would it be better if it was guaranteed and I sounded like this? That would be TCP trying to do streaming. If I'm doing streaming, it might be more like, hey, how are you doing? Let's see what's going on. There might be little pieces missing here and there, but I'm exaggerating too. Although last night in our Spanish class, we had some of that going on. When you can have enough packet loss in UDP that you can understand it. But as Mike said, the important thing is that it goes quickly and it keeps moving, because your brain can put together what was being said from the pieces. Make sense? There is no verification. There are no handshakes. It's like taking a water hose and spraying the whole room, and hopefully you all get some water to drink. Or TCP would be, I go out and buy a bottle of water for everybody and give one to everybody, and you all have your own bottle of water. That's a guaranteed delivery. Most of what we do is TCP, because most of what we do, we want it to get there. If I'm putting a file on my GitHub for a program, I want it all to be there. If I am doing something at my bank, I don't want to lose $50. If I'm buying something from Amazon, I don't want to pay $1,000 for a $20 item. So most everything we do is guaranteed. If I'm speaking on my cell phone, is that guaranteed delivery? No, it's streaming. As long as most of it gets there. You know, if I'm sending an email message, is that guaranteed delivery?
TCP.
Yeah, it uses TCP. So if you think anything streaming, that's most of what UDP does. Everything else is TCP. All right, so what do we have next? That's the layer that Jess wanted to have something to do with, right? What's the internet layer do for us?
Internet layer.
Translates the IP address into a MAC address.
Yeah, that's one of the things it does. What else does it do? It does lots of things. It's a logical address, meaning it's not assigned to hardware. If you take your laptop from here and you connect it to Wild West and you connect up to WNCC Internet, you get a different IP address. So it can change, but you need that IP address to navigate that particular network. If you had a WNCC.net internet address connected to Wild West, it wouldn't work because you're not on the same street. It also, and I'm going to go through this again just because it's important to understand, routing. Routing is very simple. My IP address is, it's never going to be that, ever. That's a fake IP address for VirtualBox to access my network card. This is a real IP address. I have a gateway. I have a DNS server. So this and this tells my computer how to route things. So my computer is literally a router. It determines if I ping google.com, so I don't want to do Goggle. That's probably some malware site, you think? Okay, so this is where I'm going, right? This is where I'm coming from. I think it was 137. How does my computer know where to send this packet? How does my computer know where to send this? Or if I'm like pinging Jess's computer, for example, we'll just pretend this is Jess's computer. Yeah, it's going to fail because I didn't get the right address. But if I ping Jess's computer, where does that packet go?
First, it goes to the gateway.
Does it? If I'm pinging her computer right here in this network?
If you both connected to one router, so it has to go to and the router is connecting you with her computer.
And it is, except the router doesn't actually connect us. A router creates networks and it allows you to go from one network to the other. If I'm pinging Jess's computer, I need to know her MAC address, and that's it.
Yeah, ARP resolves MAC address.
So MAC addresses are on switch layer 2.
Oh, if you both connected to the switch.
Right.
Not through the router.
Well, the router doesn't come in
because
those two work.
It's at home, yeah.
Yeah, they work together.
It's the next level, closer to the internet.
So I need to back up a little bit because these two work together so closely. If I ping Jess's IP address, the first thing I have to do is determine, is this, well, actually, the first thing I have to determine is this address on this network or not? So if I'm pinging 10.0.1, how does my computer know that it's on the same network as I am? What here shows you the mask. So if I'm pinging someone with 10.0.1, it's going to go directly to her computer. It won't even touch the router because the subnet mask tells my computer, no, you don't need to go to the default gateway. You just need to go directly to Jess or directly to Sean. The next step is, what if I'm pinging Google? This does not match. So I do go to the router. So I say, oh, well, my gateway setting is whatever it is, 10.0.1.1. I say, oh, well, my packet needs to go to the router. So what I need to know is the MAC address of the router to send it there. Then it passes it on until it finds that network that matches. So the data link layer and the IP layer work together to send things. So the data link layer is physically sending something, like physically sending an information on the wire from me to Jess or me to the firewall. The firewall, the router, physically sends something to the next one. Yes? Oh, I was talking about this in class the other day. Let's bring this up. All right, so we'll see if this works. See how good I can draw. Ooh, I can't get my pins. There we go. All right, so this. I'm on the wrong side. It's not working right. Okay, I have to draw this. Okay, so this is me. Here is my router. That's the edge of my network, right? So this little square is my router, and fortunately, my little pad is over here, so I can't draw with my little pad. I'm disappointed. So if I want to send a packet to Jess, it goes from here to here, right? And I have to know the MAC address of this, the MAC address of this. And how do I find the MAC address of that? I use ARP. And how I determine that this person is on the same network is using the subnet mask. If the first part matches, we're on the same network. If it doesn't match, my computer says, oh, I need to send it to the default gateway, which this is a MAC address to MAC address translation. I mean, not translation, but sends it from MAC address to MAC address. Now, if I had my little drawing thing, I would put PAT here, port address translation or net address translation. This is private.
Yeah.
This is public. Public and private addresses cannot mix. So the router translates my private IP address to its public IP address. My MAC address never leaves my local network. From this point on, the router sends my packet with its MAC address to the next router. And so it does go down to that layer 2 again, which allows us to get to layer 1. So when I'm communicating with a switch, I have a hardware connection, layer 1, I go up to layer 2, I'm done. So switches, wireless access points are considered layer 2 devices. Routers are considered layer 3 because you have to read the physical wire, the MAC address, and the IP address. But you go up and down the stack each time. So here, I go up and down here. It comes in, it says, oh, the IP address goes over here. It says, what's the MAC address of the nearest router that knows where that is? It goes over to here. This guy reads it up and says, oh, you're heading over there. It goes down to the MAC address, sends it physically, brings it up again. And this server over here says, oh, yeah, here I am. So the MAC addresses never leave local networks. IP addresses allow you to transition between networks. Questions? Disagreements? Yes.
So I remember you were talking about how like it takes a while for a new computer to be recognized on the network.
Yep.
And so will it go to the router to recognize it? Because it doesn't know where the IP or the MAC address for the new computer is?
Well, the first thing the computer does when it starts up is it broadcasts. If it's set for DHCP, it'll send out a DHCP broadcast saying, hello, I need an IP address. Well, the broadcast goes to everybody. All MAC addresses get it. Then the DHCP server says, hey, and so it, at that point, knows my MAC address because that was part of my broadcast. It says, hello, and we're talking MAC to MAC at this point. It says, hello, I have an IP address for you. And it says, would you like this IP address? And I say, sure. And at that point, I now have an IP address. But the MAC had to happen first before it could send me my IP address. So then I can communicate with the network. How I find out about everybody on the network is using, in the background, there's a protocol named ARP that broadcasts. So if I haven't communicated with something for a while, like I haven't communicated with the gateway for a while, this is cache, so it gets thrown away. If I don't know where the gateway is and I'm trying to ping 10.0.1.1, when I do the ping, it automatically goes down to the data link layer and says, oh, I don't know the MAC address. I'm going to send out a broadcast and someone will answer. It could be the gateway answers. It could be that Jess knows about it and says, hey, 10.0.1.1 is over here. It's this IP address, not over here. It's this IP address. Right now, I know about it. So I'm just going to say, oh, there's the physical address. I'm done. I know how to communicate with it. So it has to go IP address down to the MAC to make the physical layer back up to the IP address. So if I can change the MAC address and fool people,
So why don't I use the ARP to find my Raspberry Pi MAC address?
ARP works on its own. It's not a command you can use to find things. But you're not looking for the Raspberry Pi MAC address. What are you looking for? The Raspberry Pi
IP.
IP,
Oh.
because you're wanting to make a remote connection with an
Yeah,
application,
you're right.
and that does require an IP address. So communication does require an IP address. But we have to do translating between the logical IP and the physical MAC address. Does that make sense?
Yeah.
So it's always going back and forth. It's not really going back and forth, but I want to ping an IP address. I have to know internally, I have to know the MAC address to actually get there. If I'm going out of my network, I just have to know where the default gateway is, but I do need to know its MAC address to make that direct connection. So when your Raspberry Pi starts up on its network, it says, oh, hello, everybody, here I am. And it may send out doesn't really say that, but it does, because it's looking for a DHCP server. It says, hello, I need a DHCP server. What's my IP address? And then it sends a broadcast with its MAC address on it, which tells everybody what its MAC address is. And then the DHCP server sees that MAC address and says, oh, you can have this IP address. And it sends it from MAC to MAC. Then once you have your IP address, you can start communicating.
Or if you set up a static IP, just you turn it on and he says, here, like, hello, here's my IP address. I don't ask DHCP about that.
Right.
And if somebody already has the IP address, you'll get a collision maybe, yeah?
The second host usually can't do anything.
Yeah.
That's what can happen. Or the first one, because if they're both on the network, that creates trouble.
Mhm.
Doesn't happen very often, but I've seen it early. It's been a long time since I've seen it, but it will disable one of them from communication if they
Mhm.
both have the same IP address. But DHCP servers like mine keeps track of everybody. You know, and it's can have two people, but it keeps track of the IP address and the MAC address. So it's difficult to have duplicate IP address
Yeah.
because each device should have
Or spoof MAC
unique,
address.
if you
it will
spoof
be
the MAC,
weird.
then you could have duplicate, which doesn't cause any trouble,
Mhm.
except that that's how I get Jess to talk to me instead of the gateway, for example. I assign my computer this MAC address. How does her computer know where to go?
And another question, if you spoof MAC address, do you need the same IP to intercept the packages like man-in-the-middle attack?
You just need an IP address on the network. You're spoofing and
Any.
saying,
Not-
I
not
am
the same.
this physical address, and it'll come to you and then I can pass it on.
Because it works level lower and it doesn't matter what IP address
Right.
is.
She thinks
you
she's
will
talking
get the
to,
packages.
yeah, she thinks she's talking to 10.0.1.1.
Mhm.
But when she's actually communicating, she's communicating to the MAC address. If I spoof
Okay.
that, she still thinks she's pinging 10.0.1.1.
Mhm.
She doesn't know that I've intercepted the next layer down.
But the packages go wrong way.
Right.
Mhm.
It goes to me and then it goes to you. You don't know that I'm intercepting your packages because I'm doing it at the MAC address layer. You're seeing the internet layer, which to you is transparent. You're just talking to each other. But I'm standing there between you, listening to everything, the man in the middle. That's because we're not intercepting. I'm intercepting the IP layer, but I'm not spoofing that. I'm spoofing the MAC. So you each think I'm the other person.
And to protect it somehow, can we do in our software app level, like a tracking of the MAC address that is attached to the IP address? If it's changed, so something going wrong
Mhm.
and not send packages to that.
Right. And that would be like a host intrusion prevention or a
Yeah.
network intrusion detection system.
Yeah,
They look for those systems look for anomalies like
like
that.
something weird is happening.
And there's probably something you can do on your local computer
Mhm.
to keep track of, oh, there's suddenly there was a program I had at one
MAC
point that
address.
would keep track and it'd say, oh, duplicate MAC addresses. I can't remember
Or
what
for
the name
example,
was.
my router always had this MAC address, but now it has different. And something happened, maybe it's not my router, maybe it's somebody's or something like
So
that.
yes, there is software you can load on your computer that'll look at all the MAC addresses and say, oh, there's a duplicate here. This is not good.
Mhm.
You can do it with an intrusion detection system.
Mhm.
So there's different ways, yes, as long as because there is no security to MAC addresses. If you're on the network, you can read everybody's MAC address because everybody shouts and says, hey, this is my physical address. There is no security going on. Encryption doesn't occur at the data link layer. It can occur at the transport layer and it can occur above that, but everything below it, if you can read that part of it, you're good. An encrypted packet, you can't read the physical or anything. You can see, can you read the MAC address? Yeah, you can read the MAC address and IP address of an encrypted packet. What you can't see is what it contains.
The content.
You can't see the contents. That's correct.
Okay, I have a question. Can you
Sure.
answer that? How does that work differently with VPN? Because I know it's
Oh,
like,
there's a
how does
topic.
that time?
That's a topic. Wish I could get my drawing thing to work.
For example, a VPN.
I wish I'd have kept my drawing. So here you are in Sonia. This is your computer. Here's this firewall, which in this room, if you're connected to Wild West, that's my FortiGate in the back room. It has a public IP address. And that public IP address is registered to WNCC. So if wherever you're sending your packet sees that this is the originating IP address, which it will, if you're going to Google, and I go to Google, it'll look at that IP address and it could say, oh, well, that's from the United States, right? Because this IP address is registered to us. Okay, so if you want there's two types of VPNs. We're going to deal with the VPN that I think you're referring to, which is how do I hide where I'm surfing from? So when TikTok went belly up, you could have hid where you're surfing from and downloaded the app from someplace else. So, and Sonia turns on her software, which if she turns that on in class, then things don't work. But because what it does is it creates a tunnel to some server very far, far away that then gives her packets a public IP address that show that it's from France or something. And then from there, this gets information from Google. Oh, here's Google's up here. Yeah, it gets information from Google. Google says, oh, this request is coming from France. That's fine. You know, you can filter by IP addresses and say these are bad and these are good. In fact, my firewall has a DNS filtering in it that says, yeah, we want nothing to do with those IP addresses and those DNS host names because they're known to be bad malware sites. So when it comes back, the VPN, only the VPN knows that this packet came from here. And then the firewall says, oh yeah, I know that packet, it goes to Insonia. So this is where all that takes place. So it isolates your computer from, it's like it passes through the firewall. At this point, the packet does have the public IP address of my firewall. And it goes to the VPN server, which disguises it by giving it a different public IP address that's located somewhere else. Now, the other type of VPN, which is the one businesses use all the time, I'm at home, I'm in my slippers and my pajamas, I'm sitting, you know, in my easy chair, and I want to go to work on the servers here. I want to like update them or something. So here's my servers, and this kind of looks like the server room here. Sometimes I have cables all over the place. It's better now than it was. So from home, I make a connection to my firewall. And then the firewall says, oh, well, let's make an encrypted channel. So now I have a tunnel, an encrypted channel between here and here. Oh, by the way, and Sonia's VPN does the same thing. When she connects to this, remember the little tunnel I drew? That's all encrypted, so nobody can see what's being passed. But to have it passed, the IP address has to be exposed or it can't go anywhere. But what's in it, nobody knows. So nobody knows what's going on between here and here because I've now established an encrypted channel to my firewall. From here, it's as though my computer is in this room. I can then connect it to my servers and reboot them and update them. In fact, that's what I do. If I need to install software on these desktops, I make sure they're all on. During the weekend, I'll remote into here, connect up to the computers and add whatever software I need. It's very common for network admins and people working remotely to do this. Like Mike, for example, has one
Yeah.
set up for his server and stuff at home. He can
WireGuard.
connect- Yeah, he uses WireGuard
Mhm.
and he can connect up to all his stuff at home, wherever he is in the world. I can connect up to this network anywhere I am in the world. The IT people at WNCC, same thing. The people at Riverstone, is that where you're at? Yeah, Nick's interning at Riverstone, same thing. The network admins would have remote access. Because you don't want to have to run into the bank if all you have to do is reboot the server or fix a tiny problem, reset a password. You know, you can do that from the comfort of your easy chair and your pajamas.
And actually, all the remote IT works uses
Mhm.
VPN to connect to the remote servers and work there.
Yep.
And this is actually the main purpose of VPN.
Mhm.
That one that you explained in the beginning, it's like a side purpose. It's
Yeah.
if you need to reach TikTok, for example, or something that is blocked in this country, you need a server outside to go through that
Right.
server.
And that's really all it does.
Yeah.
They make there's a lot of advertisements and stuff that say, oh, you want to make your browsing secure and all this, you got to buy our VPN for $10 a month or whatever. Well, that's a bunch of hype.
Yeah.
You're not really more secure than I am, not using a VPN, but it does hide where you're coming from. And it can do some other services. I've never dealt with this. I mean, they could be running antivirus on there to make sure you're not downloading viruses. I have no idea.
And about what Sonia asked, how about VPNs with MAC addresses? I checked my WireGuard, and WireGuard it creates the network, VPN network, but it uses the MAC address of my current network card
On
So-
your computer.
on my computer. It uses the same MAC address.
Because when you're doing a VPN, you are part of the local network.
Yeah,
So when you connect to your network at home, your MAC address is used because the channel is transparent. It's
Yeah.
like you're on the
so
network.
it's based on the same MAC
Mm-hmm.
address, and
That's interesting. Glad you looked into that.
yeah,
That makes sense, now that you said it. Because the VPN means you're now part of that network. You're just not there. That's why it's called virtual private.
it means if somebody spoof MAC address to mine, it will be able to intercept my VPN packages as well.
If they can be here,
Mhm.
they'd have to be somewhere in that connection.
In my VPN network.
Right, somewhere in there in the WireGuard, because if they were just here, they can't get your packets. If they were just here on another computer in your network, they can't get your packets. Somehow they have to break into this channel
Hmm,
to get in there.
hmm. Even in this local network, but not in mine VPN.
Oh, yes, you're right. Okay, sorry, I was saying the wrong thing. You're correct. If I'm in here, I can spoof your MAC address.
Yeah.
Or I
and
can
you-
spoof
and
the
you
MAC
will
address.
receive
Yes, you're
The
right.
packages from my VPN as well.
Yeah, because here it's
They directed to my MAC address.
and it's unencrypted on this end of it. Yes, you're correct. I was
Yeah.
going somewhere else and I was lost.
Good thing that they are encrypted because WireGuard encrypts.
Right, everything's encrypted for anybody outside, but on Mike's network here and inside here, you can spoof MAC addresses because it's all in the clear at that point.
Hmm.
On your computer, it's in the clear. In the network, it's in the clear. Where it's not in the clear is between you and the firewall, which is going across the public internet. And as Mike said, that was originally why we did VPNs, is so we could work from home. We could manage lots of people, but everybody that works remotely, especially, during the pandemic, all of that, they used VPNs like this to work from home. You can work from home with your phone over your VPN. You can do all kinds of stuff from home.
Mhm.
If you get a job doing remote, whatever, tech support or computer coding, it's all going to be by VPN or some encrypted channel. It's very common. Oof, that was a lot.